Recently in our Year 12 studies, we've been looking at Newton's laws of motion. In particular, we've looked most recently at Newton's second law of motion. Newton's second law of motion tells us that if you apply a force to a body, a massed body, a body with mass in kilograms, then the body will accelerate. Acceleration is a word that we use in our everyday language. We use it alongside of deceleration. In our common and everyday language, these words mean to go faster, to slow down. If we can think of an example, you're getting onto the freeway. A lot of us are doing our driving lessons over the next couple of years. And when we move onto the freeway using the on-ramp, we have to increase our speed to match the speed limit on the freeway, which is very often 100 kilometers an hour. The artery road leading to the freeway might be operating at 60 or 70 kilometers an hour, and we're going to increase our speed. We're going to accelerate. Equally, if we're leaving the freeway, then we're going at 100 kilometers an hour. We get into the off-ramp, moving off the freeway into one of the other roads linked to it, and we're going to have to decelerate, get slower, to move from 100 kilometers an hour down to the more sedate 70 or 60 kilometers an hour as we leave the freeway. So acceleration has already got use in our everyday language. In physics, acceleration for us is a very important word, and it means all of this, but it also means a lot more, because in physics, we describe acceleration as a vector. Vectors have magnitude and direction. You know what else is a vector? Velocity is a vector. A lot of us are learning how to drive at the moment, and we're learning how to get on and off the freeway using entry and exit ramps. Let's imagine you want to go for a drive down south. If you're driving down south to Bunbury, you'll be on the freeway going at a steady speed in a constant direction. Your velocity as you head down to Bunbury might be 100 kilometers an hour. That would be your magnitude. And your direction would be south. Well, what if you're heading down to Bunbury and you haven't got onto the freeway yet? So you want to get onto the freeway. You've got to use an entry ramp. In that situation, you're going to be approaching the freeway. You're not going to be going 100 kilometers an hour. You'll be going 60 or 70 kilometers an hour. And as you get onto that ramp, that on-ramp, that entry ramp, you're going to need to increase your speed to get up to the appropriate speed for the freeway, which is 100 kilometers an hour. This is a really basic idea of what you might see if you were doing this. You might be coming along your artery road, whichever road that might be, and then you turn onto the on-ramp. From here to here, you've got to increase your velocity. You've got to increase the magnitude of your velocity, which is your speed. And you might be going at 60 kilometers an hour here, but down here you have to be going at 100 kilometers an hour as you merge into the traffic. And that might take a little bit of time. This is acceleration. In this situation, the velocity that you're moving at is changing. It has a magnitude to start with. It has a magnitude to finish with. It has a direction all the way through, which is down. Your acceleration, it has a magnitude and a direction. The direction of your acceleration is down. The direction of your velocity is down. And so because they're both in the same direction, we're going to see that very normal experience of the car getting faster and faster and faster as you approach the on-ramp. Okay, let's have a look at this situation. You're coming back from Bunbury. You're coming back from Bunbury and you're thinking to yourself, I've got to get off and head home. My house is over this way somewhere. As you're coming back from Bunbury, you're going at 100 kilometers an hour. Your velocity is 100 kilometers an hour north. Now, you're going to have to change that velocity, and it's going to take a certain amount of time as you leave the freeway in this exit ramp. As you leave the freeway, your velocity is going to be 100 kilometers an hour, magnitude, direction, north or up. As you approach this intersection, you'll slow down to 0 kilometers an hour. Now, your acceleration has caused this to happen. But in this scenario, where your velocity was up and it is decreasing as you approach this intersection, by definition, your acceleration must be south or down. Over here, when we were entering the freeway on-ramp, our acceleration was down, our velocity was down, and so we got faster. As we were leaving the freeway, we slowed down. Why did we slow down? Our initial velocity was up, but we slowed down because our acceleration was a vector with magnitude and direction in the opposite direction to our velocity, and so we slow down. In common language, we say decelerate. In physics, we can say that if we want to, but what we're talking about is that the acceleration is opposite to the initial velocity, and so we get slower. The acceleration is negative, it's negative acceleration. So for us in physics, acceleration is a vector. Acceleration and velocity, both of them are vectors. They've both got magnitude, they've both got direction. But the direction does not have to be the same. The direction of the acceleration does not have to be the same as the direction of the velocity. In this situation, the direction of velocity and acceleration are the same. We have a trolley that's moving across the table to the left. It's being accelerated by a small mass that's suspended by a piece of string over a pulley back to the trolley. The trolley is moving faster and faster to the left. You'll notice over here in my diagram, I've placed a little orientation indicator. I'm saying with this little part of my diagram that everything to the left is positive and everything to the right is negative. In this situation, the trolley begins at rest, 0. In this situation, the trolley moves faster and faster to the left. The velocity is to the left. The acceleration is to the left. The trolley is getting faster. If we were to drop a ball from a height of 2 meters, then we would see the ball get faster and faster as it approaches the ground. The velocity of the ball is down. The acceleration of the ball is down. They're in the same direction. The ball gets faster. But what about after the ball hits the ground and bounces back up? When the ball hits the ground and bounces back up, its new velocity is up. Its new acceleration, though, is still down, because gravity is still pulling the ball down, so its acceleration is down. In this situation, as the ball rises, its acceleration is opposite in direction to the direction of the velocity. The ball slows down. The ball is fastest just after it hits the ground. The ball is slowest at the peak of its run, where it is at 0 velocity. The acceleration is always down. So where we see velocity and acceleration in opposite directions, we will see the object slowing down. If we include an indication of orientation in our diagram, where we say that up is positive and down is negative, then in that situation we see that we can say that the velocity is up, or we can say that the velocity is positive. When we look and we say that the acceleration is down, we can say that the acceleration is negative. When one of these is positive and one of these is negative, then in that situation we're going to see that the object will be slowing down. When the velocity vector and the acceleration vector are in opposite directions, the object will slow down. In summary then, if the velocity and the acceleration are in the same direction, the vehicle will get faster. We say the acceleration is positive. If the velocity and the acceleration are in opposite directions, the vehicle will be getting slower, and we might say that acceleration in that situation is negative. In common language, we would say that this is decelerating. In common language, you'd say this is accelerating. In physics, we recognize the vector nature of acceleration. So this is positive acceleration, and this is negative acceleration, where negative means opposite to the direction of the velocity. I hope that was useful.